In this example, we're going to calculate the average density of the Earth. Recall that the Earth does not actually have a uniform density, but rather it has regions of varying densities. Suppose we break down our Earth into three distinct regions. We have the inner core, the outer core, as well as the mantle, as shown by the following diagram. So we have the inner core, this region is the outer core, and this region is our mantle. Now each one of these regions has a specific density value as shown by the table. The density for the inner core is 13,000 kilograms per meter cubed. The density of the outer core is 11,000 kilograms per meter cubed. And the density of the mantle is 4,400 kilograms per meter cubed. Now the radius of the inner core is 1,220 kilometers. The radius, or the distance, from the beginning of the outer core to the end of the outer core is this distance here, and the distance from the beginning of the mantle to the end of the mantle is this distance here, shown in red. So the red region shows the mantle, the green region shows the outer core, and the blue region shows the inner core. So in order to calculate the average density of the Earth, we first have to calculate how much volume each region takes up. So let's begin by calculating the volume of the inner core. To calculate the volume of the inner core, we make the assumption that our Earth is a perfect sphere. So that means we can use our formula for sphere. The volume of a sphere is equal to 4/3 pi radius squared. Now the radius of the inner core is simply 1,220 kilometers multiplied by 1,000 because we want to use meters. So we take this quantity, multiply that by 1,000, we cube it, multiply by 4/3 pi, and we get approximately 7.606 times 10 to the 18 meters cubed is the volume of this inner core. Now what about the volume of our outer core? To find the volume of the outer core, we have to find the volume of this entire sphere and then subtract the volume of the inner core. So to find the volume of this entire sphere, we simply take our formula 4/3 pi multiplied by 3,480 times 1,000, because we want to convert that to meters, and cube that, and that will give us the volume of this entire sphere. And then we subtract the volume of the inner sphere, and we get a value of 1.69 times 10 to the 20 meters cubed. And finally, to find the volume of the mantle, we follow the same exact procedure. So we take the difference of the radii cubed. So r mantle cubed minus r outer cubed, where r mantle cubed is simply 6,380 kilometers multiplied by 1,000 to convert that to meters. So that's the radius of our mantle. And the radius of the outer region, this region, is 3,480 kilometers multiplied by 1,000. So we cube those values, take the difference, multiplied by 4/3 pi, and we get a volume of 9.19 times 10 to the 20 meters cubed is the volume of this mantle region. Now, in the next step, we want to calculate what the actual volume of the Earth is. To calculate the actual volume of the Earth, we simply take 4/3 pi radius cubed, where the radius is the radius of the Earth. It's 6,380 kilometers. So we take this value, multiplied by 1,000, cube it, multiplied by 4/3 pi, and we get a volume of 1.09 times 10 to the 21 meters cubed. Now, to calculate the average density, we simply have to use the following formula. So we take our density of the inner region and multiply it by the ratio of the inner volume to the actual volume of the Earth. So this fraction will tell us how much of this density is contributed, how much of the inner density is contributed to the average density of the Earth. So we add that to, well, we take our density of the outer region and multiply it by the fraction of the outer volume to the actual volume of the Earth. So this fraction tells us how much of the outer core's density is contributed to the entire average density of the Earth. And finally, we sum that with the product of the ratio of the volume of the mantle to the volume of the Earth multiplied by the density of the mantle. So we plug our quantities in and we add and we get a value of 5,506 kilograms per meter cubed is the average density of the Earth.